In this video, we're going to understand about the heat budget of the Earth. Now, by the term heat budget, you can easily relate that it is referring to the balance between incoming heat absorbed by the Earth and the outgoing heat escaping it in the form of radiation. And if this balance is disturbed, then Earth would get progressively warmer or cooler with each passing year. Let me illustrate with an example. Let's assume that the amount of incoming solar energy at the top of the atmosphere is 100%, which means 100% of sun rays are hitting the exosphere, the first and the outermost layer of the atmosphere. Now, while passing through the layers of atmosphere, some amount of energy is reflected, scattered and absorbed, and only the remaining part reaches the Earth's surface. So 35% of sun rays are reflected back to space, even before reaching the Earth's surface. So this 35% of reflected radiation is called albedo of the Earth. In other words, albedo means how much of the sun's energy is reflected back into space. Now, as the remaining 65% sun rays enters the atmosphere, 14% of it is absorbed within the atmosphere by water vapor, dust particles and other atmospheric gases. Now, the remaining 51% of sun rays is actually absorbed by the Earth's surface. I hope till here it is clear. Now it's time for the Earth to radiate back the 51% of heat which is received from the sun. In other words, it's time for terrestrial radiation. So this time the heat travels in vertical manner and there is a term given to it. It's called convection. So as the heat rises, 34% of the heat will be absorbed again by the atmosphere, which includes water vapor, dust particles, horizontal air movement and other atmospheric gases. The remaining 17% of the heat is radiated to space directly. If you notice, in total 48% of heat is absorbed by the atmosphere, that is 34% from terrestrial radiation and 14% from incoming solar energy. And this 48% of heat absorbed by the atmosphere is also radiated back into space. Now the total radiation is 48 plus 17 is equal to 65%. And if you remember in the beginning, we saw that 65% of heat makes it into the atmosphere. So what we can conclude from this calculation is that if the amount of heat received in the form of insolation equals the amount lost by the Earth through terrestrial radiation, which in this case we found it to be equal, that means the Earth maintains its temperature. Or in other words, the Earth neither warms up too much nor cools down too much, despite the huge transfer of heat that takes place.